We've had a lot of questions from folks about starting machine shop businesses and how you get work. We really recommend that you watch the video we did on how we quote work, but we had a job come in this morning and I thought this is a perfect example of hopefully how folks can see a little bit about how we operate on a job shop level and the service that we're providing to customers. We've got this part drawing right here. And this is exactly what comes in from a customer. It's not a perfect dimension, drawing, and tolerances. You've got to understand what they mean. So let's take this and let's go into Fusion 360 and let's model it up. But one of the things you've got to understand is the service you're providing. Some of your customers aren't going to be machinists. They're not going to have perfect drawings. You've got to think for them and make sure you understand the questions. And in my opinion, you need to do that and go back to them with one set of questions. Don't come back to them 2, 3, 4, 5 times and say, hey, I keep realizing there was something missing in your drawing. It's not their fault that stuff's missing in your drawing. It's your fault if you don't go through it, completely understand it. That's why I like to model things up right away and then hit them up. Let's make the part. New sketch. Just drag here and it is 3 by 3. So I hit 3, tab 3, enter. Right click, press pull. I'm going to say this and -2. I hope that works. I forget. Yeah, there we go. Perfect. Now we've got our block that's 2 inches high. Now we're going to sketch a circle right here. It's going to be in the middle so we can actually create some lines. Lots of ways again to do this. Oop. Kind of funny how you I mean, my videos don't bother me anymore at all, but you still get nervous. So it's a 1.25 inch diameter hole. Great. We're going to click on these 2 lines and say over here for construction. Here we go. And then right click on this, press pull, and we'll say they said it's 1.5 inch deep, so -1.5. Okay, let's create those counterbore holes. The only way I know to do this is to sketch a point, which feels like it's not the right way to do it. Must be a better way. But sketch a point and then do create hole, face point, choose our point, and we'll do counterboard, depth of 2 inches for 2 all the way through, diameter 0.257. We'll drill it with a letter F drill for clearance on a 1/4 inch tool, and we know the counterboard for a 1/4 20 socket cap screw should be 0.385 and 0.25 counterboard, or sorry, 0.39. Click OK. Now you've got one all the way through. Let's create the pattern. Create pattern rectangular. Now instead of clicking on it, I would suggest choosing the option down here. That makes sure you select the whole thing, and then directions. Click there. Click there, and I just go over here, quantity 2, distance 2 inches, quantity 2, distance 2 inches, and you see we're wrong there, so if we just go distance, I think -2, we'll get it over, perfect, and click OK. Now we've got our pattern, but you see it's not centered correctly, so let's go back and right click on this sketch, edit sketch, and now we can just dimension this first hole, which we know from the drawing is 1/2 inch over and 1/2 inch down. Stop sketch. Now we've got that, and the last thing we need to do is put a hole over here. So we'll do sketch here, and we'll come over to the halfway point, and that's 0.201 would be the thread, would be the drill diameter, and we'll just sketch it down 0.75. The top, and we will then stop sketch, right click, press pull, choose that little guy, and what we can do here, it actually is kind of quicker, just go up like that, click OK. And now we've got our part model. All right, CAM. I know right now I'm not happy with Fusion 360 in the coordinate system, so what we're going to do while we're still in the model is construct axis through cylinder and click right there. That creates a line right through the middle of the part. Now, model, CAM, and we're going to set up a job. So click Setup, New Setup, and Orientation. I'm going to change from Model Orientation, which is somewhat arbitrary, and I'm going to choose Select Z-Axis and X-Axis. Z-Axis we know we want to be this guy. pointing down in the wrong direction. So if I click flip, that actually is exactly what I want. It's on the top, and I always laugh, but if you kind of do point your arms up in the air and bring them down, that's Y positive and X positive. Click OK. We're going to start off with a drilling op. We're going to do tool, uncheck the filter. 16 for me is a spot drill. 1, 2, 3, 4, 5. And we're only going to feed down from hole top, negative 0.1. Okay. Another drilling op. Tool 208 is a letter F for me. I think we might get a post issue with tool numbers above 200. We'll see. 1, 2, 3, 4. Now here I got to be careful. I want to go and change the height from the model top because otherwise it would wrap it into the part I selected, which is the 1/4 inch down, which would not be good. And bottom height, I want to go just negative 0.15 to make sure I go all the way through. I'm going to now use a 1/2 inch drill to remove a lot of the material from that center hole. So tool 9. I love this recipe. I talk about it a lot. 1175, 5.5. Click here. And what we're going to do here is hole bottom, but 0.05. We don't want to go all the way to the bottom of that hole. Leave a little bit of material. This one, we want to do a full retract. There we go. Peck of say 0.1 should be fine. Now we actually want to go back. This is very important to peck that letter F drill. I forgot that. Full retract, 0.06, that's fine. Looks like that's some formula of diameter, which is perfect. Okay, now the next thing we've got to do is get out this material here. So let's use the hog shear. I had the tool in my SolidWorks library, so I went to Manage, Tool Library, and I just re-imported my same library, and now that tool is there. Don't know why. Normally I felt like it updated live based on whatever was in my tool library, so I'll have to pay attention to that. But now 2D adaptive clearing tool, and we'll check the hog shear, which just so we see, we're going to run at 5100 and 30 inches a minute. We can plunge and wrap it at the same, by the way. Should be fine. We'll choose this bottom ring here, but what we're going to do is bottom height, selected contours. I hate stock top. Model top makes me feel better. And we will do stock to leave 1000. Now, I'm probably not going to get a tool path. Right, because it's trying to ramp in at too wide a radius. So if we go down here to the ramp helix, we've pre-drilled this to 1/2 inch, so you could plunge, and in fact the shear hog can plunge, but let's do this. Let's change the helical ramp diameter to something pretty small, 0.1. Let's see if that'll let us, any sort of helix is better than a straight plunge, and sure enough, that's great. It's going to take forever to get down there like that though, so let's increase the ramp pitch or angle to say 10 degrees. Perfect. I like that. Now, we can't cut this in one depth of cut, so one last edit, is multiple depths, and I forget what the exact step down is, but we'll say 0.3 multiple depth, and that should do the trick. Looks like that. And let's just see how long that op is. One minute machine time. Actually, a little longer than I thought. Anyway, okay, now we've got to we need to come clean this back up. So 2D contour, and we will choose tool 100, which is a long 3/8 inch end mill, and that's going to come in and do the cleanup, and we will say, again, model top, and I think we should be fine. Depending on how much stock you leave, you could do it in 2 passes, but I'm always conservative. We should be fine with 1 pass. And then let's come in with say 3/16 and clean out these pockets. So we'll do 2D adaptive clearing, even though you could do a 2D contour. 3/16. 1. Okay, so let's do it this way. Click 1 just to show you. Oop, we're not getting a pattern yet. I'm sure it's the same thing. Ramp. Let's change it down to 0.1. Usually if you're not getting a toolpath, that's why. Looks fine. I'm just going to increase the plunge angle. 10. Perfect. And then what you can do is right click, add to new pattern, and we'll just choose, direction 1 will be there, linear pattern, yep, 2, and number of instances 2, and you can do, should be able to do additional direction here, 2, 2, flip direction 2, just a different way to do it. Last hole, that side 3 or quarter 20 tapped hole, so we'll do setup, new setup. Now again, I just don't love it, but I'm sure we'll get this to work for how you create the XYZ origin. So we'll say again, select Z-axis, plane, and X-axis. The Z-axis would be something like that, and the X-axis will be that. So that will mean we have to put the part in the vise like this, which is fine. We do need to pay attention, obviously, so that means that the part is going to be drilled on the Y negative. So click OK, and then it's pretty simple. Drilling, select 16. And we'll just have that be from hole top, negative 0.1. Drilling number 4, just like that, and we'll go all the way through. We went to do negative. You can see it poke through right there, and we will do deep drilling, full retract, that's fine, and we are going to tap this a new and different way. Stay tuned. Unfortunately, I can't justify buying a whole 12-foot stick of 3-inch by 3-inch aluminum, so we had to order this from McMaster Car, which just gets built into the customer price. Let's see, the big question is, what's the dimension on it? Perfect. So we actually have about 11 thou extra. The customer, I know, wouldn't care about 8 on that side. They wouldn't care if it were a couple thou undersized, but we do, even though that's a pretty decent finish, we want to clean that up with the Superfly. All right, set the part up in the DeWalt DW872, one of my favorite pieces of equipment. Make sure you leave enough material to square off the machine. Still makes a really square cut. One of my favorite pieces of equipment. Part is cold, good to go. Throw it in the Tormach, and what we'll do here is use the Heimer, and hopefully you'll be able to see just how quick it is. I love having the touch screen. We're just going to go down to the side and hit negative 1.5 because we know the part's 3 inches wide, and then negative 1.5 on the back side as well. Check it. Looks good. I always do my sanity check. Start off with tool 16. Again, quick sanity check. And here we go. Let's rock and roll. Spotting 1500 RPM, only 2 inches a minute, pretty slow. I only went down negative 0.1. Should have gone deeper. You actually want to get into the actual angle of that center cutting tool. Letter F drill. I like this recipe. It does bird's nest a hair. 2750 on the RPMs, 8.2 inches a minute. I may actually need to feed a little faster, and we're pecking about every 50 thou. All right, here we go with the hog shear. It can plunge. We have pre-drilled, so that should help. We'll see if it's too aggressive. Ooh, okay, hogging down. Yeah, let's back off that feed ramp in a little. All right, backed it down to 20 inches a minute on the feed in. We had no problem at 30 on the last part we made in that video, but we have a lot more width of cut as we're plunging here. Much better. That sounds pretty good. Bogging down a little, but I'm willing to let this run. I love this tool. You don't get chip weld. That's the amazing thing, because it's this single insert tool. I've got the coolant blast up high on my Trico system. It really evacuates the chips. It is great. You guys tell me, is there a better way to clear a 1.5 inch pocket like this? Or 1.25, I guess? We're now 1.5 inches deep. Huh, a little more strain at the end. Still, sweet. Tool 100, 3/8 inch, 2-flute carbide end mill, 5,100 inches a minute, 5,100 RPMs, 12 inches a minute. And then we'll cut out those counter bores for the socket head cap screws for the 3/16 2-flute carbide end mill, 5,100 RPM and 9 inches a minute. 2 depths of cut passes, still makes pretty quick work of it. Pull the part out and then we'll flip it back up. Remember, make sure it's pointed towards us. Double check your model. One smack of the hammer, and then what we'll do is throw the Heimer in, and we'll quickly go grab -1.5 on the left side of the X. Touchscreen makes quick work of this, folks. I love it. +1 on the back side with the Y, and Z0. Spot it, tool 16. Again, should have gone deeper. Lesson learned. And then a quick run through with the drill number 4 for me, which is a number 7 twist drill, .201 for pre-drilling ⅓20. Little cutting fluid and more to come, folks. I am really excited on this, but we have a flex arm. Actually, it would help if I tighten down the vise first. We've fabbed up a little table for it. We've got a couple of different vices for it. I'm really excited. We actually had a chance to go up to the factory and meet with the folks on FlexArm. So we're going to do a short video on that with a story behind it. Super useful tool and an interesting conversation. As you can see here, do you tap offline? I would never run the tap that deep, and probably rigid tapping, definitely not with a compression tension head. So a lot more to come on that, but I love it. Grab a test socket cap screw, great fit. There you have it, folks. That's a quick job shop job. I hope you enjoyed. Here's my takeaway for you guys. You don't need crazy, fancy, expensive equipment, especially if you can't afford it to get started or even to do any sort of work. Go look at the guy ClickSpring on YouTube, relatively new channel, crushing it. Sureline lay, the things are hundreds of dollars. He is crushing it. Go look at a guy like Keith Fenner. I consider Keith a friend. I don't think he'd mind me saying this. His equipment isn't worth that much. It's at auction, it would sell for thousands of dollars for that lathe or that mill, Bridgeport, because they're older, they may have some backlash in them, they're not commercially in demand anymore. But guess what? Keith does wonders with those machines. It's the carpenter, not the tools. Folks, someone just emailed me saying, hey, I can get this loan approved, blah, blah, blah. Look, I can't tell you what to do, but I think you're an idiot if you don't have experience or guaranteed revenue and you want to take on debt. Save your money, start small, do great work. Take pride in your work. I wish I did it every day. I try to. We're all human. We don't do it every day perfectly like we should, but it shines through. Customers love it. Deliver a great product to your customer. They'll talk about it. It will grow. It might grow more slowly than you would like. But again, that's how I've chosen to grow, and that's a question a lot of people ask me. For sure, check out the video, How We Quote CNC Work, where we talk a lot more about that. And this weekend, Saturday, August 1st, at the Tormach Open House, John Grimsmo and I are going to do a joint seminar on just that, how to run small business with a Tormach. So with that, folks, take care. See you soon.